Good morning, good afternoon, and good evening to everyone on the call. I'm happy to welcome you to a Bitnami webinar on the app developers Kubernetes Toolbox. I'm going to switch it over right now to Adnan, who is our presenter, to introduce himself. One thing before we get started, you'll see that there is a Q&A tab at the bottom of your screen. Please add questions as you go, and at the end of the presentation, I'll come back online and I'll read questions for Adnan to answer. So we definitely are taking live questions and add them throughout the presentation. Adnan?
Okay, thank you, Chris. So, hey everyone. Click next slide here. I can do that. Okay. Okay, everyone. So my name is Adnan Abdulhussein, and I'm a software engineer here at Bitnami. I work on our Kubernetes team, where I work on developing some open source software, which we'll actually take a look at in the next few slides here. I kind of like to say that I love all things DevOps, developer tools, open source software. Those are kind of my passions, I guess. In the Kubernetes ecosystem, sorry, one sec. Quit this. In the Kubernetes ecosystem, I contribute as a co-chair of the special interest group for applications. So this is basically a place where people get together to talk about how to run applications on Kubernetes. And Kubernetes has a set of different special interest groups, but this particular one is centered around running applications.
Can you increase the volume a little bit?
Yeah, brings close to me. And I'm also a core maintainer of the Helm project, which is kind of like the de facto package manager for Kubernetes, as well as the charts project. So what are we going to look at today? We're going to look at first, we're going to take a look at what Bitnami is. So for those of you who aren't familiar, we'll go over kind of what Bitnami does, where our kind of expertise are. And then we'll go into the meat of this talk, which is on the app developers toolbox for Kubernetes. And we'll take a look at what development environments kind of look like and what the trend is there. And then we'll take a look at what that looks like on Kubernetes itself. And then we'll actually look at some of the tools. Probably the most interesting part of this is actually looking at some of the tools that you can use to develop applications on Kubernetes. So we'll go through tools in various different use cases for them, and we'll take a look at kind of examples of where they make sense and look at the pros and cons of each tool. And finally, at the end, hopefully there'll be some time for a live Q&A session. So as Chris mentioned, put your questions in the box there, and then finally we can wrap up. So to start off with, what is Bitnami? So we're really the kind of global leader in application and software packaging. We have over more than 10 years experience doing this. And we've also, along the way, kind of maintained some open source projects, again, around this kind of area around packaging. We're a member of the Cloud Native Computing Foundation. And we also have relationships with all of the major leading cloud platforms, so Google, Azure, Microsoft, and Oracle. Our core kind of focus is around, again, applications. And so one of our core products, which we'll talk about in the next slide, is kind of an application catalog, where we kind of build and automate the packaging of open source applications and other source applications, and ensure that they're kept up to date and maintained. We have a large user base that kind of ranges from end users to developers, to kind of larger organizations and cloud providers, and we maintain all of these applications for them. So kind of the product that I mentioned there was the application catalog. So these are either cloud images or VMs or container images for running particular applications, typically open source applications that we produce. But we also go and produce the templates for those applications as well. So if you have an application that needs to talk to a database, or you have for example, a database that might have a multi-tier solution, so it can be scaled out and replicated. Then we provide templates, either CloudFormation templates, ARM templates, or in the case of Kubernetes, Helm templates to allow you to go and deploy those things. And you can also subscribe to our enterprise catalog to get production-ready applications delivered to your organization. Then we also have Stacksmith, which takes our expertise in packaging applications and effectively productizes it so that you can package, as an enterprise, you can package your own applications and provide them through the same pipeline. And also in an organization, you might be interested in enforcing some configuration or security or operational requirements, and Stacksmith allows you to do this. One thing that's interesting about Stacksmith is that it's actually run on top of Kubernetes itself. So we actually deploy Stacksmith on top of Kubernetes ourselves, and we've been able to build our expertise deploying and managing applications on Kubernetes with this project as well. But probably more relevant to this presentation is the Kubernetes work that we do, and we got involved pretty early on in Helm, which is again the kind of package manager for Kubernetes. But there's also some other projects that we have been involved in, collaborating with other companies as well on some of these open source projects here that are listed here. I actually work on KubeApps, which is our web UI for deploying and managing Kubernetes applications inside your cluster. And then we also have BKPR, or the Bitnami Kubernetes production runtime, which makes it really easy to configure your cluster with the monitoring, logging, and ingress you might want when you're running a production cluster. And what we do is we basically set up your cluster with monitoring using Prometheus, logging with an Elk stack, Elasticsearch, and Kibana, and FluentD, and ingress using the Nginx ingress controller and Cert Manager for providing certificates and TLS. So all of these things are all open source, and it's just a very easy way to get those things up and running when you'd have to go and manually set that up yourself. Okay, so let's take a look at development environment. So just going to kind of give an overview here. I guess, we started out developing on our local machine. So each developer would have their own machine that they'd work on, and they'd go and install whatever runtime or framework that they use of their choice for the application they're developing. And, it works. You kind of develop your code locally, and then you push it up to a Git repository somewhere. Then you go and deploy that. The issue is it's pretty far from your production environment because it's your local machine. So what ends up happening is you sometimes run into inconsistencies, such as you might have a newer version of a runtime than what your production server has, and so something you might be writing may be available on your local machine, but then when you push it up to production, it doesn't quite work the same way. So that's certainly an issue that comes across when you're using, when each developer is kind of using their own environment and there are different runtimes in use. So one way to kind of tackle that was to move to a VM approach, where you have effectively virtual machine packages or boxes in the case of Vagrant, and you can share that across your team so that everyone's working in a pretty similar environment with the same runtime versions and framework versions for their code. And it makes it fairly easy to share as well. So Vagrant did a really good job of kind of making this really easy to share. You had, in the case of Vagrant, you would have a Vagrant file in your repository, and then you'd run a command like Vagrant up, and that would go and build the VM or pull down the VM image, install any components that might need with a specific version, and then you'd have an environment that you can work with. it plugs into different providers such as VirtualBox or VMware or whatever hypervisor you might be using. So it's pretty flexible as well in that case. And this is closer to your production environment because you can now, each developer, you are now certain has a specific version of the operating system, of the runtimes and frameworks, but you also might share the same version of the operating system. So, if you're developing on a Mac, you're gonna run a VM for Ubuntu if your server's running Ubuntu 16.04, and you can share that version as well. So you can share more components with your production stack. So the idea is to just kind of get closer and closer to that. And then fast forward to now, we have containers and we have Docker, which has made it really easy to kind of, it makes VMs even more easier because you have kind of a much more lightweight footprint as you're running containers, and it's typical as well to run multiple of them. Whereas in a VM, if you start running, more than a couple, you're gonna start running into resource constraints on your machine, because containers are just lightweight processes that spin up, and they're much faster and quicker to spin up. And use much less resources. It's just a lot more. It's a lot more performant on your machine. So here's an example of what situation that you normally run into. Something works on your machine, you push it up to production, and it doesn't. With VMs and containers, we get a lot closer to where we can actually just ship what you're working on. It works on your machine, so let's just package that up and make sure it works somewhere else. So that's kind of what Docker is trying to do and what containers try to do, and we're getting a lot closer to that. As I mentioned, it's kind of common to run multiple containers in a Docker environment. This is particularly important in microservice architectures. So something like this, where you might have a front-end service that has two back-end services, like a products and a comments service, and then those things talk to a database. So this kind of architecture is getting more and more common now, especially as it's easier to run these things. And tools like Docker Compose, which are designed for developing containers locally, make it really easy to set up an environment where all of these containers are running, and you can start developing your application without having to worry about how those things are linked together, because it's all defined inside a simple file. So let's look at what this looks like when you start working on Kubernetes, because again, we're talking about, this is all about the goal of getting as close to production as possible. And if you're starting to run containers, you might use Kubernetes in production, as it's a pretty good environment to run your containers in production in. So what does development on Kubernetes look like? So going back to kind of what we looked at, you might just choose Kubernetes just runs containers. So why not just use Docker Compose to develop those same containers locally? The problem comes in when you have something like this. So this is actually taken from the Monocular project, which is one of the open source projects that we work on, and it's what powers the KubeApps hub. And what you'll see here is that you've defined all of these different services, and then we also have things like config maps, secrets, service discovery, and volumes. And these are all things that Kubernetes already gives you, but you have to re-implement them in this other format just to make it work in your development environment, which is fine for this sort of thing. Like generally, config maps and secrets, all these stuff are pretty transferable when you're working on Kubernetes, but it can get even more complicated. So going back to that diagram that we had, you might also have something like an initialization container that will run before that database container gets started up in order to run any migrations or something else that database service needs. And that's something that Kubernetes gives you, but is not easily reproducible inside of Docker Compose. You'd have to add an entry point script inside your container or do something else in order to make that work. That wouldn't easily be automatable. The other thing you might have is an ingress to your front end service. So an ingress can effectively be seen as, in the case of Kubernetes, a reverse proxy service that sits in front of your actual services, and that ingress can do things like specific rewrite rules. So it might change a path to match what the front end service expects, but the user actually contacting that front end has a slightly different path. And that's much harder to replicate inside a development environment, because then you need to have an extra reverse proxy, like an Nginx server that's sitting in your Docker Compose file, and you need to maintain the configuration there to make it act in the same way as the ingress resource in Kubernetes. You might also, in a more complicated application, need some sort of background job that runs on some sort of schedule. And in Kubernetes, there's this concept called a cron job, which effectively allows you to run a container or a set of containers on a schedule. And again, this is difficult to do in Docker Compose because there isn't a native concept of cron inside Docker Compose. The way you can get around it is by running a cron container and having a script execute on some sort of schedule. But again, it's not something that's built in, and you'd have to manage that in a separate way to how you might manage it in production. One thing that I don't like doing is having multiple ways of managing orchestration. Having to manage both a Docker Compose file as well as all the Kubernetes manifests that I would use to deploy my production application is not fun. And you can easily run into all these different inconsistencies. So if there's a way we can avoid that, that sounds good to me. Another example is if you're developing Kubernetes extensions, and in this case, you really don't have a choice. You actually need a Kubernetes API server in order to work with it. In this example on this slide here, you might have a custom API in Kubernetes for managing serverless functions, and that API talks to the Kubernetes API to then go and spin up some pods for your service. And then, as maybe some load increases, then we talk to the Kubernetes API again to get it to scale up those pods. But in order for me to build and develop this, I would need to have an actual Kubernetes API that I can work with. So all of this leads to how can we actually use Kubernetes as a development environment? So let's take a look at some of the tools. And thankfully, the Kubernetes ecosystem has kind of seen this problem over the last couple of years, and the particular space here has grown, and we're now seeing a bunch of different tools in the developer tools space, and it's kind of hard to choose now what to actually use. So that's kind of what I'm aiming to get through this presentation, is to try and give you an idea of what tools are out there and what tools might make sense for your particular use case. So first things first, we need a Kubernetes environment. So luckily there's a bunch of tools that allow you to run Kubernetes quite easily. Setting up a cluster is pretty easy nowadays. You can run it both on your local machine. You can run it in the cloud somewhere. So let's take a look at some of the options that are there. So the first one is minikube, which is probably one of the first tools for configuring a Kubernetes cluster for local development. It comes from an older tool called localkube, which was donated to the Kubernetes ecosystem, and then it turned into minikube. Basically, what it does is it will, in a similar way to Vagrant, if you're familiar with that tool, it will actually talk to a hypervisor that you might have on your system, so something like VirtualBox or VMware or HyperKit, and it will create a single virtual machine to run a full Kubernetes environment. So it'll be a single node machine that contains all of the Kubernetes components on the master. So that's your control plane and the API. And also all your workloads will also run on that same VM as well. The nice thing about minikube is that since it's been around so long, I think it's pretty stable, and it's a pretty good solution for running for setting up a local Kubernetes environment. It also works on both Windows, or I guess all Windows, Mac, and Linux, which is very nice, especially since some of the other tools don't work on other environments. And the reason it can do that is because effectively it works like Vagrant. It sets up a virtual machine, so it doesn't actually matter if you're on Mac or Windows. You're effectively going to get a VM that runs Linux and can run Kubernetes. It also has some add-ons. So there's the Nginx Ingress controller and dashboard and a few other add-ons that you can just run a command and you can enable on your cluster. So that's pretty nice if you're working with those things. It's also pretty configurable. So if you are working with alpha APIs that you want to enable, or you want to disable some APIs in newer versions of Kubernetes, then you can do that by setting the necessary flags for that when you run minikube start. And then you can also configure what Kubernetes version you want to use. So by default, it will generally launch the latest version. So in a screenshot, you can see it's launching Kubernetes 1.13. But if your production environment, it's pretty important if it's running an older version of Kubernetes. So if it's running 1.10, for example, you can simply set a flag and tell minikube to start up a 1.10 cluster. So that's all pretty nice and easy with minikube. Another simpler option though is Docker for desktop. So if you're using Docker for desktop and you're using the Docker CLI locally, you probably already have Docker for desktop installed, especially if you're on Windows or Mac. And if you go into the settings pane for that, you'll see that there's a Kubernetes tab and you can go and enable Kubernetes at the click of a button. So it's really easy to actually get and spin up. And most of the time you already have a Docker environment. So the fact that you get to reuse that is really nice. One of the key things about that is if you're doing Docker builds locally and you're tagging images locally, you can actually use those images directly inside the Kubernetes environment without having to push to an external registry. One thing to note is that Docker for desktop doesn't exist on Linux in the same way that it does on Windows and Mac, and that's because Linux runs Docker natively. So Docker for desktop deals with setting up a VM to run Docker, and that happens on Windows and Mac, but it's not necessary on Linux. So on Linux, you would need some other solution like minikube or some of the two other solutions we're going to look at in a minute. The other issue is that it's not as customizable as minikube. So if you're working on specific APIs, or you want to enable or disable APIs, you don't really have that level of control over here, and you don't have level of control over the Kubernetes version either. It's whatever is bundled into the Docker for desktop version that you have. So other two options are micro-k8s, which is from Canonical. And this is really easy to install on Ubuntu or any other Linux operating system that supports Snap. So you just do snap install micro-k8s. One interesting thing about this tool is that it installs separate binaries. So it doesn't conflict with anything already on your system. So every binary it has a prefix of micro-k8s dot. So if you want to use kubectl, you can use micro-k8s.kubectl, and that automatically points to your micro-k8s cluster. So that might be nice if you want to ensure that you're not accidentally touching a production system if you have your kubectl configured there, because you know that micro-k8s kubectl is configured for that micro-k8s environment. But it might also be confusing if you're following some instructions online and you need to copy and paste some kubectl commands, and you have to go and each time you do that, you have to go and change micro-k8s to, so you have to go and append that prefix on every time. So that might be a little bit confusing, but it's generally a nice and easy way to get a Kubernetes environment running on Linux. And then another option here, which is pretty new, like literally came out a couple of weeks ago, is K3S from Rancher, which is an incredibly, actually impressively lightweight Kubernetes distribution. So it's all wrapped up into a single 40 megabit binary, and the minimum RAM it requires to run is 512 MB. So if you look at the website, they'll say that this is a certified Kubernetes production environment and actually designed for IoT devices specifically. But you can actually run it as a local environment as well, and it works pretty well. So you can actually, they have a Docker Compose file in the main repo, and you can just do Docker Compose up, and suddenly you have Kubernetes up and running. So that makes it really nice to quickly set up and tear down. You might not want to run your Kubernetes environment locally, though. You might want something a bit more powerful, or your machine might not be that powerful. So in this case, you might look towards remote options. The good thing is we're in a world now where we have a lot of managed Kubernetes services. So there's Google Kubernetes engines, there's the Azure Kubernetes service, there's the EC2 container service for Kubernetes, which is from AWS. And all of these services make it really easy to just spin up and tear down clusters. And in the case of Google Kubernetes Engine and Azure Kubernetes Service, it's actually pretty fast as well. These also might be closer to your production environment if you're already using some of these services for your production environment. So that might be a benefit of that as well. And you also get a lot of the cloud features that you'd get that you won't get if you're running locally. So you can set up services to create public load balancers. You can get actual volumes, storage connected to your pods as well. And all the other cloud features that you get. So that's kind of nice if you're working on something that makes heavy use of that. Although generally these things are transferable also locally. So whilst they don't work in the same way, they can be used. The other thing is that generally these services are pretty opinionated and don't provide as much configuration. So you wouldn't be able to enable or disable APIs sometimes. I think in the case of Google Kubernetes Engine, there's a way to turn on all alpha features, but you can't easily pick and mix and pick exactly what APIs you want to enable or disable. So that might be one downside if you're doing something specific, but if you're using a pretty common version of Kubernetes and you just want to split up with all the basic features, a managed service should be more than fine. The other thing you might have, and this isn't necessarily a different option to the previous option, is a shared development environment. So previously I was kind of talking about how quickly they are to spin up and tear down, and that makes it nice to just have a quick environment, use it for a bit as a developer, and just tear it down, and that's kind of just my environment. But you might also want to share a development environment with your team or other members. And there's some advantages of this. One is that you can make more use of kind of internal load balancers because this cluster is already configured and set up, and it's long running. You can spend the time to configure it to make sure that it only works over a VPN. You can also again configure an ingress and also set it up with DNS so that you can get nice domain names to the services that you're testing there. So you can have myservice.kubernetes.internal.mycompany.com. And that goes over your VPN and is only accessible through that. And that's something that we actually have set up at Bitnami and is what we use a lot of the time for developing on Kubernetes. And this probably, because again, it's a long running environment that your team would be configuring, it's probably closer to your production environment because you're actually spending the time to configure it and maintain it. So this would, I guess, really get you as close as possible to it. One issue is that with any multi-tenant environment, there is a possibility that you can tread on other developers' toes. This is probably more of a concern when it comes to a development environment, because generally, especially in the case we have here, with our development environments, we give all developers kind of full access to the cluster. And so there's a lot less control over what's actually happening there. But it's still a good option if you need to easily share what you're working on within the company. Okay, so we've looked at several different options for starting up a cluster, and we have our Kubernetes environment configured now. And we may have our application running on there as well. So now what does it actually look like to develop an application on top of Kubernetes? You might, if you're already doing this, you might actually be familiar with this cycle where you are building images. So you run Docker build local. So you make some code changes first of all, and then you run Docker build and you have your new container image. If you aren't using a local environment like Docker for Desktop or even Minikube, then you might need to push up to a registry so that wherever your Kubernetes environment is, it can pull down that new image that you just built. And then you want to go and update your actual deployment to go and point it to that new image that you've just built. On Docker for Desktop and Minikube, you can actually avoid the push to registry step, which is quite nice because, as I said, in Docker for Desktop, you're sharing that same Docker context. So every Docker build that you do will be shared with that Kubernetes context, and it can just discover that that image already exists, and it doesn't need to go and pull that. In the case of Minikube, you're not sharing this same Docker desktop by default, but you can run a command to get that Docker context, and then any Docker builds you do from that will be present in that environment. But again, if you're using a remote environment, you'll need to push it up to a registry, whether that's public or a private registry, depending on what you're working on. And then updating the deployment, you would probably use whatever deployment tool that you use. It could be as simple as doing a kubectl set image and updating the image in a deployment or a pod or whatever with the new image that you've just built. Or if you're using Helm, you might do a Helm update to get that new image rolled out. So this is quite an arduous process. It's very manual as well. You have to go and manually run a set of commands to actually get your changes up there. So one set of tools in the Kubernetes ecosystem has basically worked around automating this cycle. There are two kind of notable solutions in this space. One is Draft from Microsoft, and the other is Skaffold from Google. In the case of Draft, the way it works is so in your directory, you have a bit of code. It will figure out what runtime and framework you're using something it calls packs, which define the configuration for different runtimes. And from that, it will generate a Docker file and a Helm chart for you to then go and deploy that application. Once that Docker file and Helm chart is generated, it actually spits it out into your directory, so you can actually go and make further changes on top of that if you need to add something that isn't defined in the pack. But it's pretty configurable and flexible in that case. And then you would run a command like draft up, and then every time you make a code change, it will go and redeploy that chart in your environment. Skaffold is similar, but it works with any directory containing a Docker file. So it doesn't automatically generate anything for you. It's not smart enough to figure out what kind of runtime or framework you're using. But it will take any directory that has an existing Docker file, automatically build that image, and then you can configure it to tell it where to replace that built container with. And the nice thing about Skaffold is it's independent from any deployment tool. So you can continue using kubectl or Helm or any other deployment tool, and it will work alongside that. In the case of Draft, it's all using Helm. So if you're not using Helm, or if you're not deploying using Helm, then you might want to try something else. But if you are using Helm, then it makes for a great experience as well. The other thing about Skaffold is it's really pluggable. One of the neat things about it is that you might not have a Docker environment locally, and you might be doing all of your container builds remotely on something like Google Container Builder. Say your builds might take a long time or require a lot of resources. That's really useful because you can just offload it to the cloud. So in your Skaffold pipeline, you can replace that build pipeline to point to get it to do a remote build, and then continue with the pipeline once that's done. The other interesting thing about these two tools is, although they're very focused on the development cycle, they can actually be used to give you a base to actually go and deploy to production as well. So in the case of Draft, it's generating your Docker files and your Helm charts, and you can then use that as a base to then go and deploy to production. And in the case of Skaffold, because the whole build push deploy pipeline is so pluggable, you can actually go and configure it to work in a CI/CD environment to go and deploy to production. So it's kind of nice because it starts off with a kind of development field, but then you can easily take that to production from there. One of the issues, though, with this whole cycle is that sometimes they're not quick. Containers are not quick to build. It depends on obviously the runtime and the framework that you're using, and also how big the applications that you're developing are. Generally, if you're developing small microservices, it's not too difficult. You might have a small Go service that you're building, and rebuilding that can be fairly quick. But if you're doing anything else, then those things can take a very long time. And it's kind of the new compiling. So in some cases, you might already be working on something that already has a development server that is optimized for this case, where it's difficult, where it's hard, it takes longer to build an image for, but running in development is much faster because that server is optimized for that. And in this case, there are two tools that I've seen in the space that work on top of this notion. There's Telepresence, which is accepted into the CNCF, but originally from a company called DataWire, and Cloud Native Development, which is from a company called Octito. So this is really useful if you are working on a front-end application, for example, which like either an Angular app or a React app, and generally the build times for those apps take quite a lot of time. But with a development server, you can just start up that development server, and then once it's done the first compile, subsequent compiles as you make code changes are a lot faster. They also might have specific configurations that are useful for development servers. So in the case of, again, a front-end application, they generally will set up a WebSocket that will then, in your browser, will be used to poll for changes. So every time there's a code change, it will automatically recompile, and then your browser will pick that change up through the WebSocket and refresh. So you get this fast development workflow. So actually, we use Telepresence to develop Kube apps in the same way. So Kube apps, again, as I mentioned, is our web UI for managing applications on Kubernetes, and so we use Telepresence to get that kind of fast iterative workflow on that. But let's talk about the way it works. So Telepresence, effectively what it does is it will replace a deployment already running inside your cluster with a two-way proxy. And that proxy will basically proxy any requests to your local machine. And then that local process will also proxy any DNS requests or TCP requests through that Kubernetes cluster. What that means is that it makes that local process feel like it's running inside that pod in the cluster, but it's actually running on your local machine. It's really neat because you get access to all the environment variables that you want, all your volumes. You get service discovery, so you can easily point to other services running in the cluster through the in-cluster DNS that Kubernetes has. And it works pretty well. It's pretty stable as well. It's been fairly stable for us on Kube apps. There's a newer tool that does a similar thing here called Cloud Native Development, except it doesn't deal with a proxy. The way it works is it replaces a deployment with a pod that will run your development server, and then it will essentially sync all your local file changes with the pod. So it's almost the same as running that dev server on your local machine, because as you make code changes, those changes will be synced with the pod, and then that development server running inside that pod will pick up those changes and update the app accordingly. So I mentioned earlier on a little bit about building Kubernetes extensions. Generally, these are custom controllers, which is the concept in Kubernetes where you watch API resources and you do something when those resources are either created, updated, or deleted. These extensions are generally written in Go, and the main reason for that is because all of the Kubernetes libraries are written in Go, so it just makes it a lot easier to integrate with if they're written in Go. The core Kubernetes controllers themselves are also written in Go, so there's kind of a defined way of doing that. More recently, there's been some new tools to help build these extensions. So for a while, it was very difficult to actually go and build these, but there's a few tools here now that help with this. One is Kube Builder, which is from the Kubernetes community itself, and it would just effectively scaffold out an application in Go for writing a controller. Then there's the Operator SDK from Red Hat, or previously CoreOS, which specifically is based around the concept of operators, which I'll discuss more in the next slide. But effectively, the components are the same. The fact that there's a controller or a custom API resource to watch on, and then it will boilerplate out your code and give you specific portions, functions to actually go and implement the logic that you need. Another interesting one is meta controller. So this is nice because you don't actually need to write in Go. It will set up sort of boilerplate, but then the actual logic that you need to write to reconcile the controller can be written in any language, I think, or whatever the supported language is that meta controller supports. So you could write it in Python or JavaScript. I think you can also write it in a more declarative language like JSON, and you can see what other runtimes that you can use on the meta controller documentation. So it kind of gives you a kind of serverless model of interacting with the Kubernetes API. So that's one that might be interesting if you're not developing with Go. So finally, you want to look at how you actually ship your Kubernetes apps to your production clusters. And I'm going to go very briefly over this because this is probably a whole other talk in itself, to be honest. But there's several kind of tools to highlight here, I guess. The most obvious one is kubectl. So you're probably familiar with this one. If you've used Kubernetes, it's the main Kubernetes command line tool. It's very low level. So you'd use it to interact with all the Kubernetes APIs directly, but it isn't really great for managing applications as a whole because there's generally multiple APIs that you need to talk to. So one thing that makes this a lot easier is Helm, which again, we talked about as the package manager for Kubernetes. And basically the idea with Helm is that you package your whole Kubernetes app and all the different APIs and resources that you have inside that into a single bundle, which they call charts. And you can easily share those charts through Helm repositories. So basically it just makes it much easier to package up applications and share them across and also go and deploy them and manage them. We have also worked on a tool called kubectl, which takes a slightly different approach to kubectl and Helm. I would say it's kind of almost in the middle of those tools. It's not a full management experience in terms of your application, but it's a little bit higher level than kubectl. And the main kind of focus on this tool is around a sort of a GitOps workflow, but also the fact that the templating that you can use with kubectl is with a JSONet language, which I won't go into too much detail. If you're interested in finding out more about that, you can go ahead to the kubectl GitHub page and learn more about that. But it's a very declarative templating language, and in some more complex scenarios where you need to reference many different files for your application, that might be more useful to you. And it's also, again, focused around a GitOps workflow, so it fits in nicely to a CI/CD pipeline. The last one here is operators, and operators are interesting and not necessarily a replacement for the tools I just mentioned. But the main thing about operators is that they are designed to manage the lifecycle of a particular application. And the way they do this is they're built as Kubernetes extensions. So with an operator, again, as I mentioned in the last slide, there's the operator SDK, which allows you to build out these things. But you'd have a controller, and then you'd have a custom API resource, and your operator would basically watch on that API resource. And whenever one is created, it would go and deploy an application. Whenever something's updated, it would go and update an application. And then along the life cycle of that application, it can there's logic to go and take backups and maybe do upgrades if they're kind of self-healing and also scaling and all that good stuff. The reason why I say that they're not necessarily a replacement for some of the tools above is because you might actually use them in conjunction. So Helm can be used to go and deploy operators. So you might package your operator that you've built for, say, MySQL into a Helm chart so people can easily deploy that operator. And then from then on, you can use that operator by creating those API resources that your operator watches on. Again, I'm not going into too much detail around operators because they're also a whole concept in themselves. But you can learn more at this link, and there's various other links I think that you can get to from that, specifically around the operator SDK, that will help you learn more about that. So that's all I have. I guess we can move on to Q&A now.
Yeah, so this will be fun because we have way too many questions for the amount of time we have. So first of all, please, if you have questions, continue to put them in the Q&A channel, and Adnan will get back to everyone. But we clearly are not going to hit all of them, so we're going to do this like a game show.
Okay.
I'm going to ask a question. You're going to be brief. How's that?
Uh-oh.
Okay, so here we go. In no particular order. Is it possible to share data between containers that are running in different pods?
So yes and no. Typically, it's much easier to share data across containers in a pod because all of those containers are guaranteed to run on the same machine. When you're sharing data across different pods, the only way to do it would be to mount a particular volume on multiple nodes, which you can do on cloud environments. For example, you can do this, specifically block storage. You can do this if only one of those nodes is in a read-write mode and everything else is in a read-only mode. So you wouldn't be able to write to that same volume from all the containers. But that would be one way to do it. Another way to do it would be to use a volume that can be mounted multiple times in read-write mode. So NFS, it comes to mind. So if you have an NFS server, you can use NFS volumes and share those between pods.
Okay. This is one that came in that I think you actually already answered, but it was asked twice, so I'm going to ask it. Because during the Docker for desktop slide,
you can go back to it.
You had, this question was asked, and I think you actually covered it on the automating the cycle slide. So the question is, how can I expose a service contained in Kubernetes through a domain?
Through a domain, okay. That gets harder with Docker for desktop. So with Docker for Desktop, when you expose a port for a particular service, you actually get that port on localhost, which is useful because you can just go to localhost and then whatever port. To do that with a domain, you might need to use an ingress resource. So you can actually set up the ingress controller, for example, on your machine, and then you need to point your domain to your IP address in order for it to actually resolve. Or you can use you can set up an etc host entry to make that domain route through the loopback interface.
Good. How can I integrate with Bitbucket build?
I'm not really sure what Bitbucket build is, but if it's a container builder similar to the Google container builder, I don't know if Skaffold has integration with that, but it might do. It's pretty pluggable, so I would look into the documentation for that.
Speaking of Skaffold, you had already covered Skaffold, so you may already have this covered as well.
Mm-hmm.
But the question was, do you have experience setting up Google Container Tools Skaffold Dev for multiple configuration files to support team development in shared Kubernetes clusters?
Okay, so the question is about setting up
Skaffold Dev for multiple configuration files to support team development in shared Kubernetes cluster.
Okay. I guess it's a little difficult to answer without more context. I would imagine that for that to work in multiple environments, you might need, you might have scaffold files set up in different directories. But yeah, I'm not sure I fully have the context for that one.
Okay. How can I expose a service contained in Kubernetes through a domain?
So again, you'd probably use the ingress resource here. If you're running on a cloud, then you might have ingress with Nginx ingress controller and maybe cert manager or something to automatically set up TLS for that domain as well. But the ingress will basically allow you to set a host name and then tell it which service to reverse proxy to. And then that will configure whatever ingress controller you're using, typically it's Nginx, to then point that domain to your service. Actually, this is one of the things that the Bitnami Kubernetes production runtime will set up for you if you in a really easy way, so that it's all configured for you and you can just go ahead and use that ingress resource. A lot of the charts in the Helm repositories as well will generally have an easy way to turn on ingress. It's kind of expected as a resource that exists in your environment. So a lot of them will have an option like ingress.enabled equals true and then ingress.host equals mydomain.com. And that will configure your application with that host name.
Kubernetes is not recommended for production, long runtime, load balanced, shared resources, multi-node service, ? So I think the question is Kubernetes not recommended for production, long runtime, load balanced, shared resource, multi-node service?
I'm not really sure what the question is getting at really, but I would say that Kubernetes is a pretty good environment for running those kind of applications in production. There are some things that Kubernetes won't be great for, particularly if you need, one of the issues with Kubernetes is that you have a cluster of machines and you might need an application to use a lot more resources, or you might need a dedicated machine for a particular application. So that in that case, it might not be useful. But Kubernetes can also get around that as well by allowing you to specify what nodes you want a particular application to run on. So say you have in a cluster, you might have 3 large nodes with higher memory, and then 3 other smaller nodes. You can actually tell Kubernetes that you want your particular application or one particular application to run on the larger nodes and another particular application to run on the smaller nodes. So it's pretty flexible in that case as well.
Can we manage multiple containers in a single pod?
Depends what you mean by the multiple containers in a single pod. If you mean in the case of a development in case of like these development tools. So things like Telepresence, for example, that will replace the deployment with proxy. That will, I think, only replace the first container in the pod, and then the rest of the containers in the pod are untouched, if I remember correctly, although that might have changed since I've used it. But generally, I don't think these tools necessarily work too well when there are multiple containers that you need to develop.
Does Kubernetes work with other containers than Docker builds, such as OpenStack, etc.?
So Kubernetes has a pretty pluggable runtime interface. It actually uses since I think Kubernetes 1.6 or 1.7, it uses the container runtime interface. And that allows whatever container runtime you're using to be pretty pluggable into that, which means you can use runtimes like Rocket or I'm blanking on some container runtimes, but there's Containerd, for example, instead of full-blown Docker. So I don't know if that particular one that you mentioned, what was the one, sorry?
Can I tell you? I thought you already answered it, so I
Oh, okay. No worries.
OpenStack. It was
OpenStack, yeah. So I'm not that familiar with OpenStack, unfortunately, so I don't know where that fits in. But if it supports the container runtime interface, then it would be supported on Kubernetes.
Got it. What would be a best practice if I need production QA development environment with Kubernetes? Create a cluster per environment or something else?
Oh, I love this question. Okay, so you have two options in this case. You might have separate clusters, and this is actually what we do at Bitnami. So we have a separate cluster for our development environment, and we have a separate cluster for our production environment. And I think we also have a separate cluster for our staging environment as well. And they all just have different use cases, and they also might have different levels of control from certain developers. One of the nice things about that is with a cluster that's just a development environment, you can give full access to developers to that cluster, and they can go and play with it as much as they want. But then, in production, obviously, you want a lot more control over that. Kubernetes works pretty well in a multi-tenant environment, so you can actually do this with one single cluster. Specifically through the use of namespaces. So you might have a namespace for QA, a namespace for staging, and a namespace for production. And each of those namespaces have different levels of control and who can access them. So both are perfectly fine ways of doing it. It might depend on how large your organization is or how large your team is, what you're deploying to it, and the amount of resources that you might need. But effectively, both are. I would argue that maybe separate clusters is a little easier to manage because you might. One thing with one cluster with a production environment is you want to be very careful that that you don't accidentally give control over something in production that a developer shouldn't have control of, which could lead to some issues down the line. Whereas if you know you're operating on a completely different cluster, then if that thing breaks or if it's harder to tread on what's actually running in production in that case. So that might be one thing to consider. But generally, I think both are perfectly fine ways to run this. Okay.
This is our last question.
Okay.
And I'm going to just pick one out of the air. And again, everyone who submitted questions, thank you very much. Adnan will get back to everyone with the answers. Anyone who put them in the chat before, I've captured those as well, so those will all go as well. And then I have a wrap up after this. What is the primary? Oh, whoops! I'm purposely not asking anything that's Bitnami specific. Do you know tools for templating Helm as
Ansible does?
As Ansible does. For example, you have one Helm chart with app and a tree in dev for it, dev prod QA, for example.
That's an interesting question. So I guess I'm not as familiar with Ansible to really understand how that works in this particular environment. But one thing that does come to mind is this is actually where, so when I kind of mentioned the difference between kubecfg and Helm, this is actually one of the reasons why internally we use kubecfg for some things, because it makes it easier to have a base template and then make modifications on top of that template for our different environments. So for staging, we might have a different host name. For production, we might have a different host name. And with JSON, it's very easy to take an existing template and then make a change to a certain field or selected fields, and then generate the full template. So you might be interested in looking into kubecfg if that's what you're looking for.
Great, thank you so much. Thank you for playing along with my how fast can you talk. I want to thank everyone again for participating. A few questions that came up during the presentation. We will have a recording of the presentation available that will go out. It'll go out in the next 2 days. All the questions that have been asked have been captured, even the ones that were in the chart in the chat area, and so we'll make sure that those are sent along as well. Thank you again for everyone who participated, and if you want to follow up with Bitnami, you can go to bitnami.com/Kubernetes. You can actually see on the screen the different options that Adnan had just made available. And you can also reach out to Bitnami directly at info@bitnami.com. Thank you very much.
Thanks, everyone.
Thank you for your time.
Thank you.
Okay, so.